Well, Joey, in this video we're going to create a 1 peg deep smart building block in Solid Edge. Before we do that, we're going to take a look back at the block we made in the last video where we made our smart block, and we have our variable table, and we were able to change values in our variable table to update the size of the block quickly and all of the features updated properly. That worked perfectly for nearly every size of block except if we made a block 1 peg deep. When we tried to make a block 1 peg deep with the previous model, we see this hollow cylinder popping out of the side of our block and our model no longer working for us. So these building blocks use a different system when it's 1 peg wide. So we're not going to use this block for 1 peg wide blocks. We're going to go back to the third video in this series where we made this single 1 peg block, and we're going to reuse this file. We're going to add variables and some formulae into it to create a smart part. We're going to be a little bit quicker than the last time because all of the principles are the same as the last video, so we'll just skip through doing that and create the part. So we have our base coordinate system displayed and we see the y-axis here. As I click on this dimension here, we see it displayed. It's parallel to our y-axis. So I'm going to call this block depth y. Click on this one here, and that's parallel to the x-axis. So I'm going to say block len. And if I click on this one, you can see that's our block height. Okay. So we got those done, and we haven't got a whole lot else. It's going to be a 1 peg wide block, but we want our x to vary. So for the moment, I'm just going to change the value of this. So I'm going to say 7.8 plus 8, and that's expanded out to a 15.8 millimeter long block. And I just want to have a look at that now. So we want to do what we did before. We want to have this peg up at the end of the block. So I click on the peg feature, click edit profile, and it shows the circle for the peg as a fully constrained sketch. I'm just going to window select around the center of our sketch, and has highlighted the center mark. So I'm just going to press the delete key, and that doesn't seem to have done anything for us. So I'm going to click on the sketch, and now I'm going to press the alt key and drag the center away from there, because I think it looked like it was constrained around the origin of our coordinate system. Now we have a blue circle. I want to add a dimension back for the diameter of the peg, and 4.8 millimeters is correct, so I just hit enter, and I'm going to add dimensions to constrain the position of the peg. So we want to make the peg 3.9 millimeters from the edge. Press 3.9 and hit enter, and 3.9 millimeters from the other edge. 3.9 and press enter. Now our sketch is fully constrained. I can put in another dimension there, and that's 3.9. It's a driven dimension, it's not driving. Okay, so I can just click this box to exit the sketch, and it's looking for a name of the extrusion. So I'm just going to call this maybe parent peg and hit enter. I'm just taking a look now. Yeah, so we have a cutout here and a cutout here. Okay, so I'm going to create a pattern. So I go up to home and click on pattern. And we want a rectangular pattern and placement type by sketch, selection type feature. And if we go to the prompt bar, it says click on a feature. And I'm going to select the peg here at the top. And I'm also going to select this hole that's immediately under the peg. I'm happy with that selection. So I'm just going to tick this little box. And if we go back up here, our prompt bar says click on a planar face or reference plane. And I'm just going to click on this top plane here. And now our prompt bar is saying click for the first point. And for the first point, I'm going to hover over our circle until the center mark appears, and then click on the center mark. And I'm just going to hold down my alt key to avoid selecting a key point and just click. All right. And I'm going to select smart dimension. I'm going to measure the distance of our dimension from the end of the block there. That's 3.9. And we want the same here. I'm just going to make that dimension 3.9. We're not actually too worried about this dimension here because it's always going to be a 1 peg wide block. I'm just going to give it an arbitrary value of 3.9, but it doesn't really matter because we are creating an n by 1 pattern. There will only ever be a single row of pegs in this part running parallel to the x-axis. So our sketch for our pattern is fully constrained. So I'm going to tick this little box, and if we go down to our pattern, it's previewing our pattern and looking for a name. So I'm just going to call this peg pattern X. Okay, and I'm just going to finish. And if we look at peg pattern X in our variable table, we can see the different variables here. If we look at the variables in peg pattern X, we have a 2 here. I'm going to try changing that 2 to a 1, and we see our peg disappear. So it looks like this is the variable that drives the number of pegs along the x-axis. So I'm going to call this nx peg count. And we can use that. So we can go up to protrusion 1. We can go to block len x. In the formula box, I can press equals, and I'm going to say 2 multiplied by 3.9 plus 8 multiplied by bracket, and I'm going to click nx peg count minus 1. Close bracket and enter. Okay, so that's our variable. And now let's just test that out. So I'm going to try changing nx peg count from 2 to 3. That seems to have updated, and the holes underneath have updated as well. And I changed from 3 to 6, and that is updated too. So that all looks good. We can do a quick PMI smart dimension. So this should be 3.9 to the first one, and then 8 millimeters between pegs. So yeah, that's looking good. 8 millimeters between pegs, and for the last peg, 3.9 millimeters to the end. So that all looks exactly like we want it. I'm happy with that. Everything's working. So we just want to do a feature on the bottom now between these pegs. We want to add a little peg as well to help the fit. I'm going to try and make things a little bit easy on myself here. I'm going to do the sketch on the top, even though the feature will be underneath. So I'm going to go to home. I'm going to hide the PMI, and I'm going to click extrude. And it says create from coincident plane. I'm going to click on this plane here, this top face of our part. I'm going to draw a circle here, and I'm going to use this project to sketch command. Click OK. And we're going to use create as construction. I'm going to click on the top face of the peg we based our top pattern on and click accept. So I'm going to create a line from this circle, and I'm just going to hover over the edge of the circle until the center mark appears. Then click on the center mark. And I'm moving the cursor until the line snaps to horizontal. We see the angle displayed at 0 degrees and the horizontal glyph next to our cursor. I'm just going to click even though the line isn't the length I want. And now we're still in the line command, and it wants to draw another line starting from where this line ended. So I can just right click to get out of that command. And I'm going to click on smart dimension, and I want this line to be 4 millimeters. That looks good, and it's fully constrained, that line. And now I'm just going to go to home, connect. I'm going to hover over the edge of this circle, click on the center mark when it appears, and I'm going to click on the end of the construction line we just created. And now I'm going to use a smart dimension, and we're going to make this diameter 3.2 and press enter. And I'm going to press this tick mark to exit the sketch. And now it's looking for a distance. It's a little bit weird. So looking at our extents here, we're in automatic extrude, which is okay. One-sided extent, which is okay. And looking at the type, I'm actually going to use extrude from to extent. We could have went with a finite extrude as well, but we're going to do this for a change. And for the from, select from surface, I'm just going to choose this face here. Now it's saying select to surface in our prompt bar, so I click on this face here, and it's looking for the name. So I'm going to call that parent inside peg and click finish. And now we have that. And similar to blocks we created in the past, we want to create a pattern for this, and there's going to be one less of these than there is for the pegs on the top. So I'm going to start the pattern command. We're going to go with a rectangular pattern, placement type by sketch, and our pathfinder is saying click on a feature. So I'm just going to click on our parent inside peg, tick that little box, and now it's saying click on a planar face or reference plane. And yeah, we could select this face inside, we could select this lower face, or we could select this upper face. I think it's just a little bit less cluttered to use the upper face, so I'm going to click there. We have options to select the number of items to pattern. That's not something I'm going to worry about in this dialog. We can do that in the variable table. And the prompt bar is saying click for the first point to define our pattern. So I'm going to select the center point of the circle of our parent feature, and I'm just going to try not to click on any key point. I hold down the Alt key to be sure and click. And now we're going to create some smart dimensions to define the pattern. So first of all, we'll measure where our parent feature is. That's 7.9 millimeters from the end, and we want our pattern to always grow and shrink and always leave 7.9 millimeters from the other end. So I type in 7.9 and hit enter. And again, we're not too worried about the height of this rectangle, since our pattern will always have a single row of pegs. We are only worried about the X dimension. For the Y dimension, I can type in 3 millimeters, I can type in 3.9, it doesn't really matter. We'll never have a peg along here. We'll be using a separate part. We'll be using this part to create blocks that are more than 1 peg wide. Okay, so we're back to our 1 wide block. So now we have a fully defined sketch, and I'm going to tick this little box, and it's asking for a name for the pattern. So I'm going to call this inside peg pattern X, and I just hit enter to finish that command. Now we can see we have 2 of these, and let's just take a look. Our inside peg pattern X is here, and if we look at this variable here with 2, maybe I'll try changing that to 4 to see what happens. And yeah, we can see that that has changed the number of these pegs. So we know there's something going on there, and it looks like that is the variable that changes the number of these pegs. So I'm going to go to the formula box, I'm going to press equals, I'm going to go to peg pattern X, expand that, and I'm going to click on the variable nx peg count, and I'm going to, we've gone back to the formula box here, I'm going to press in -1 and hit enter, and now our pattern has updated. We have 1 of these halfway between each peg, which looks good. And if we were in doubt, I could take a look at that. So I can go to the base reference planes and just click on our front plane and go to PMI, click on section by plane and click this tick box and finish. And if we look at the front view now, there's our section. That looks bang on. Yep, I'm happy with that. We'll hide that section view, hide our base reference planes, and we'll hide our PMI. So now we've created our 1 peg wide part that will grow and shrink with our block. Let me just confirm that now. We change our NX peg count from 6 to 22. Our block has grown and the pegs have followed along as we would want them. That all looks good, so I'm happy with that. In our next video, we're going to model this part. We'll get creative with extruded cutouts. We'll use the split command to split a body, the union command to join bodies together, and the thin wall command to hollow out features. Bye Joy, thanks for watching.